Factorising a non-monic quadratic trinomial. So our last video was on factorising a monic quadratic trinomial. And so that was three terms where you've got the highest power is x squared, but the coefficient is 1. So that's the video we just looked at. Okay, but this video, we're doing non-monic quadratic trinomials, and that means the coefficient of x squared can be anything. Okay, it does not, well, firstly, it won't be 1 because we're going to be looking at non-monic examples, and monic examples have a 1 here instead of a number other than 1. So for this video, all the numbers in front of x squared will not be 1. Okay, now there's many different methods all over the internet for factorising non-monic quadratic trinomials, but this is my favourite method, especially for students who are strong or capable in mathematics. Then this is the way I would go because it is efficient. So with all my classes, I usually make them use this method for a little while, and if they really hate it, I offer alternatives. But at the very beginning, I say, give this a go and stick this out before you try anything else. So it's very similar to the method I showed you for monic quadratic trinomials. So it's where we basically fill in the brackets straight away. So you look at your leading term, which is 2x squared, and there's only two possible terms that you can put as your starter. You've got to have a 2x and you've got to have an x. Okay, and that will often happen. There are definitely examples where you don't just have, so for example, if this number's not prime, like if it was 8, then yes, you could have 1 and 8 or 4 and 2. And if it was 12, you could have 6 and 2 or 3 or 4 or 12 and 1. But you will get better at knowing which numbers to choose. So it's not exactly as... the trial and error is not as complex as you think. The next thing we want is we still want two numbers to multiply to give 6, because don't forget, whatever numbers go here, they will have to multiply to give this constant term. So you just need to come up with two numbers that multiply to give 6. And I get that there's more than one possibility. There's 3 and 2, there's 6 and 1. I recommend picking any, because you will see that you just need to pick any combination. I just chose 3 and 2. I could have chosen 6 and 1. Let's switch them and just show you I can pick another set. All you have to do is check your choice. And the way I like to do a check, and it's the same way as in the last video, is do an outside-inside check. If I multiply the outsides, I get 2x. If I multiply the insides, I get 6x. And at the beginning, you'll need to write this out. But once you get good at it, you'll do it mentally. Now, that's a problem, because my outside-inside check is supposed to give me this term, and it didn't, and that means I've chosen the wrong numbers. So when you choose the wrong numbers, you just pick another pair. So instead of 6 and 1, I'm going to choose 3 and 2. Okay. So now I'm going to do my outside-inside check again. So the outsides, well, this time around I get 4x when I multiply the 2x by the 2, so that's what I'm multiplying first. And then I'm going to multiply the insides, the 3 by the x, okay? And that gives me 3x, and look what I get. I get the 7x that I need. So it turns out that I want to put a plus 2, and I want a plus 3 to get the 7x. And you should be able to do a quick little visual check, which is 2x times x, that's 2x squared. That's 4x, that's 3x, that gives me 7x, and plus 6. So that really isn't necessary if you do your outside-inside check, but I think when you're first learning this, it's worth checking your answer thoroughly anyway. Let's try it again. Once again, here we've got an example where the leading coefficient is prime, so really we can only have 3x and x. So half the work's already done for you there, okay? And I need two numbers that multiply to give 14. So it could be 14 and 1, could be 7 and 2. I don't know what it is. So I actually, what I'm doing right now is picking the wrong combination on purpose, but I want you to see what happens when it's the wrong combination. So let's do 14 and 1. I'm not going to worry about minuses. I always put the minuses in right at the end, but I can visually see that 3x and 1, that's 3x, and 14 times x is 14x. That's either going to give me 17 or 11, and neither of those are, neither of those are positive 1x. That's what I'm really trying to get, this green term here. So I've gone about it the wrong way. Now, I could always swap them. If I wanted to, I could make that 14 and make this a 1. Let's do a quick check now. That's definitely not going to happen because 3 times 14 is 42. So you should be able to see, and it does get easier, much easier, when you're in the wrong. Okay, so what I'm going to do now is switch over to the other pair, which is 7 and 2. I'm going to put down a 7, put down a 2. I don't know whether the 7 belongs there or 2 belongs there, but I'm just going to try. So when I multiply the outsides, 3x by 2 is 6x, and the inside would be 7 times x, which is 7x, and there we have, I can get my positive 1. To get my positive 1, I must have a minus 6 and a plus 7. So that's when I deal with the minuses. I only do it right at the end. So if I want this term to be a minus 6, well, the 6x comes from multiplying the long bracket, this one here. So that means that's where I'm going to add my minus to get minus 6, and that means I'll add the plus 7 here because the 7x comes from getting those two together there. And then I'm done. So straight into the brackets, and I can do a check again. 3x times x, that's 3x squared. The long gives me minus 6x, which I have here, plus the 7x, that gives you positive 1x, which is the middle term, and then 7 times minus 2 is minus 14. So it does work. All right, let's have a look at another one. Once again, we've got only one possibility for my starters, so that's 5x and x, and I'm going to pick two numbers. So if you're feeling confident, I would pause the video and give the choosing of these numbers a go. You've got more than one possibility. You've got 1 and 6, 3 and 2, and we don't know where to put them. I am just going to do the first thing that comes to my head and do 3 and 2. And I don't know if that works or not yet, but I'm about to find out. But you will start to be able to, as you put the numbers down, you'll start thinking, oh, that will give me this number. So if I do my outside, that's going to give me 10x. That gives me 3, and I can already see it's 13. And so what I want is, that's interesting, isn't it? Because that's not going to work. 10x and a 3x. Could this be a more interesting question than... Well, the reason why it's not going to work is if I want it to get 13x, I need to do... Well, could I do it this way? No. So that's going to be 10x and 3x. I've got to do it with a plus and a plus. I can't do minus and a minus because that'll give me minus 13x. Let me look into this some more. Is there another way I can get 13x? 6. No. 3. Aha. Isn't that interesting? This is why it pays to be very good at doing your trial and error. So if you look at what I did before, I put the 3 and the 2 down and I was checking whether it actually worked. And that's when I came unstuck. So if I do my outside check, let's just follow through what I just did. The outside check here, so I follow this line here, then I'm going to get, let's rub out the signs actually as well. When I do that, I'm going to get 10x. And the insides gives me 3x. But the reason you heard me pausing, and it's good for you to see me go through this process, is that how am I going to get minus 6 if I have a and get the positive 13? Because if I wanted the 13, what I was going to do was make that positive 10 and positive 3. But then I'm not going to get this minus 6. So it made me think something's gone wrong. So then I had to go and reassess. So if students don't check their work properly, they're going to think that they're ready to go and that they're finished. But really, that's wrong. So I'm going to keep going back to the drawing board. I've got the 5x and the x. And this time around, instead of doing a 3 here and a 2 here, what I did was I switched the numbers. And what I can see now is that if I do my outside check, outsides, insides, the outsides give me 15x, the insides give me 2x. And if I want positive 13, well, I'll just subtract the 2. And that means if I want to subtract this 2x, the 2x comes over here from multiplying 2 by x. So I'll make that negative, and I'll make this term positive. And now what I have, if you check these last terms, the minus 2 and the positive 3 will now give me the minus 6 that I need. I also have already checked the 13 by doing 15 minus 2x, and I've already checked the 5x by doing my starters. So it turned out that was actually a really good example showing you where something looks correct, but if you do not check every single term, especially this one here, you could think that you're finished when you're not. So checking is the key part of this process. If you do not check, it's very easy to make lots of mistakes. All right, let's have a look at this one. This one's a little bit harder because there's more choices. There's 4x and x as my starters, and there's also 2x and 2x. And there's nothing wrong with having more than one option, okay? So I don't know what's going to work. I'm going to put down 3 and 2. Maybe it's 3 and 2 here, I don't know. Well, let's see it through. Let's just do the trial and error. So I'm going to do my outsides and I'll do my insides. So 4 2's will give me 8x, and 3x times x will give me 3x. That's looking good already. If I want to get minus 5x, which I do, I will need a minus 8 and I'll need a plus 3. And the 8 comes from this term here. So that means I'm going to put a minus with my 8 and a plus with my 3. And there is no need to look at this possibility now. All right, 2 for you to do. Okay, I've given you 2 where the leading coefficient isn't prime, so you have to think about it. So I want you to pause the video, give these a go. If it takes you 10 minutes, don't worry, because like I said, you will get faster. So pause the video and unpause when you're done. All right, let's go. So for me, I'm just going to do 3x and 2x. I find that, and this doesn't always work, but I find that going with not this number, but some of the smaller factors to often be more helpful. Now let me try and be in my guessing. I'm not just randomly guessing. I'm actually thinking of this number, and I'm most importantly thinking about this number. I want to get 17. So what I'm guessing is that if I put a 3 here and I put a 4 here, I can already see that that will give me a 9 and that will give me an 8. So it's not that you're just randomly putting numbers down. You're actually thinking about what numbers should go where. So 9x and 8x does give me 17x. And they're both going to be positive. So I'll just put a plus there and I'll put a plus there. Now, with this 9x, it might be wrong. I'll follow what I said before and I'll do 3x and 3x. This one's tricky too because the 8 and the 9 have more than one possibility. So let me guess that for the 8, I think I'll go 4 and 2. Once again, I'm not going for 8 and 1. I'm just going for some of the smaller factors. So it doesn't matter where I put them because they're both 3. And let's do the outside-inside check. That's 12. And that's 6. I'm doing all right with my guess and check. So we've got 3x times 4 is 12x. 2 times 3x is 6x. Now, if I want a positive 6, well, then I would want to subtract the 6 and keep this 12 positive. So I'm going to have a positive 12x, and I'm going to minus the 6. And then, as you can see, when you put your signs in the right place, everything else will work out. So minus 2 times 4, that's a 2 there, if you can't tell, will give me the minus 8. I've already checked the 6x, and I've already done the starters correctly. So I've covered all my bases.